Hi, in this video session, we're going to look into the understanding of this particular code snippet. The question asked is how many bytes of memory is leaked in this code? As we know that any memory which you allocate dynamically, it has to be deallocated explicitly. In case if you do not deallocate the dynamic memory, then it will result into memory leakage. How do we allocate memory dynamically? With the help of the functions like malloc or calloc or realloc. And how do we release the memory? With the help of free. Now, if you observe this particular code out here, in the first line, I've created an array and initialized the string literal called as Sikander. Second line, I've used strdup function, pass the data, and then capture the pointer, and then next line, I'm trying to print it. Have I explicitly used any of the malloc or calloc or realloc? The answer is no. So the first thought it might come is like, since there is no memory allocation function explicitly, so there should not be any memory leakage. Now the next thought might come like, okay, since the question is asking about memory leakage, probably you have created an array out here. This array also has to be explicitly deallocated. In case if you don't deallocate, it might result into memory leakage. That is a thought you might basically get. So you might even think that 10 can be one of the options. When you look at the other two options out here, we might see that, okay, this particular data out here has 8 characters. And if you include the null character, it will be 9. So this overall code could be quite confusing, right? Now let us try to understand by executing this particular program and also try to check out like how do we check out if there is any memory leakage or not. Now first, let me try to compile this program, GCC followed by, I just given the file name strdups.c, compile perfectly. I'm going to execute this. And when you execute this, you can just see that I'm basically getting the output, which is the data is consisting of string literal, Sikander, and even the pointer is basically considering the same data as Sikander. And I did not get any message of any memory leakage or not. Because by default, when you try to compile and run, you won't see any memory leakage. If you want to see memory leakage, then there are two ways. While compiling, we can use the option like fsanitize equal to address. And if you try to run this program, if there is any memory leakage in your program, it's going to showcase that. And here I could see that there are 9 bytes of memory leaked in this code. Okay, so there is a memory leakage, and the memory leakage is basically 9 bytes out here. Why is this 9 bytes? The number of characters in this plus 1. That is the reason why it is basically 9 bytes. Now, where exactly the memory, okay, is getting allocated? It is not about this particular line, right? In case if I just say, if I try to comment this line, let me try to comment this line here. And if I try to run this, I'm using sanitize and observe, there is no memory leakage. So it is not that line number 7, it is resulting to memory leakage. It is something to do with line number 9. Line number 9 is basically trying to do this memory leakage, right? Here you can just see. So what is happening behind the scenes of strdup, right? In strdup, what really happens is like first you had an array here. It was in the main function. In the main function, what you do it is you create this array. But this array, which is called as data here, data, which is 10 bytes, this is allocated in the stack segment. Stack segment, stack frame of the main function, and any memory from the stack segment will be deallocated automatically. Whereas when you use this strdup and you're basically passing this data as an argument, okay, so here there'll be a pointer which is going to receive this, okay, address to this block, right? Meaning it's basically going to refer to the starting address of this. And inside this, what it does is it tries to determine how many characters do we have in the string, and accordingly, it reserves this memory. Okay, and this memory, what it reserves is basically from the heap segment, and it copies the data. It copies the data, whatever we had it here. Like for example, we had this Sikander, okay, and along with the null character, yes, along with the null character, there was also one more byte, which is basically null character because an array of 10 characters. Here, this was 9, and then this Sikander. with a null character. This was basically captured. And remember, this memory is allocated in the heap section at the runtime, not in the stack segment. And then what it does is it basically returns a pointer to this particular block. Why it basically used heap, why not in the stack? Because if it had allocated this memory in the stack segment, then once it come out of the strdup function, the memory of the stack segment would have been lost. So pointing to a deallocate memory would result into dangling pointer, right? So for that, it basically created a block in the heap and then it returned it. Now, okay, the frame for the stack frame for strdup is deleted, but since this was from the heap section, it is not deleted. Okay, now it becomes your responsibility here to release it. Okay, since you haven't released it, it is resulting into memory leakage. So how do we overcome this problem? We need to explicitly write, like after this, we can say pre, we can say PTR. Okay, this will result into clearing of that memory. And yes, for free, we need to include the stdlib.h, and you can just see no memory leakage. So I'll just try to use this stdlib.h. Observe, no memory leakage as of now, right? So from this, what we basically learned is strdup internally allocates a memory in the heap section and returns the address of that heap block. And it is your responsibility to free that memory. Fine. I hope the concept is clear and the right answer out here is 9 bytes. Right. Thank you.